So knowing how to use the intercept form of quadratics is very important because it has a lot of applications, not only in Algebra 1 but when you move up to Algebra 2. Again, quadratics that are in intercept form are in the form a times x minus p times x minus q, where p and q are your x-intercepts. Now, other words used for x-intercepts are roots or solutions. There you go. So they mean the same thing. Okay. On this slide, you will see that for any factor x minus n of a polynomial, for example, x minus p is one factor, and so is x minus q. So any factor of this form, okay, n is a zero of the function defined by the polynomial. So it's a zero. That's the other term that I have not written here. It's also called a zero of the function because when you copy the factor and make it equal to 0, right? If you copy that, x minus n is equal to 0, and then you move the n to the other side, then you will get x is equal to n. So this is actually a solution, a zero, a root, or an x-intercept. So knowing that is very important in writing a quadratic function. So let's take a look at this example. Write a quadratic function in standard form. So standard form means we're going to write our final answer in the form ax squared plus bx plus c. It doesn't mean that you're going to start with that. It just means that your final answer has to be in this form. So write a quadratic function in standard form that passes through -9, 0, -2, 0, and -4, 20. So remember the placement of zeros here. It's important because it tells us something. These two numbers are actually zeros, right? They are zeros of your function, so that means they are x-intercepts. So if they are x-intercepts, -9 can be used to write one of the factors, so we can write it in the form x minus n. So how are we going to do that? And how are we going to arrive at this formula? So to begin with, we're going to use the intercept form because we are given two intercepts here. So these are your intercepts. And why are they called intercepts again? Because their y coordinates are 0, right? So let's begin with the standard, not the standard, but the intercept form. So f of x is equal to a times the quantity x minus p times the quantity x minus q. So where do these p and q come from? They will come from the given intercepts. So it will now become a times x minus -9. That will make the negative and the other negative positive. So that will turn to positive 9 times x minus -2 minus times the other negative will change that to positive. Okay, so where does the value of a come from? Well, we don't know. Could it be 1? Sometimes a is 1. How do we know when it's 1? Normally, if they don't give a third point on the parabola, then we assume that a is equal to 1. Let me write that down. So if no third point is given, a is equal to 1. So if a is equal to 1, then we're done, right? But since we're given a third point, we have to use that to find the value of a. So how? This will be our value of x, and 20 will be the value of y. So it's a regular ordered pair that fits in the graph. So that means when you substitute it, you will change f of x, which is your y value, to 20. So our original f of x will now turn to 20 equals, we don't know what a is, so we just bring it down, times the quantity x, okay, x is negative 4, so negative 4 plus 9 times negative 4 plus 2. So 20 is equal to a times the quantity. Negative 4 plus 9 is 5. Negative 4 plus 2 is negative 2. So if you simplify that, you get negative 10. So 20 is equal to negative 10 times a. If you divide both sides by a, you get a is equal to negative 2. So now that we know the value of a, we can write down our final answer in intercept form, and we get f of x is equal to negative 2, that's our a value, x plus 9, x plus 2. Okay, so in the equation, you don't substitute your third point. I copied this from here, okay, but I went back to a and changed the a value to negative 2. Is it done? No, not yet, because you have to write that in standard form. So this is where your past lessons and chapters will be very useful. So it means that you're going to rewrite this in another form. You can do your box method, your rainbow method, however you want it. So let's try this. Negative 2. I'm going to multiply this by x. So x times x is x squared. And then that's 2x, so x squared plus 2x. The one at the bottom will be 9x times 18, or plus 18. There you go. So if I combine like terms, I get x squared plus 9 and 2 together is 11x plus 18. Now, I have a constant negative 2 outside. So if I distribute that, I get negative 2x squared minus 22x minus 36. And this is the final answer that we're looking for. So now that we know how to use the intercept form to write quadratic functions, let's extend what we just learned to cubic functions. Remember what cubic function means? The degree of a cubic function is 3. So in other words, the highest exponent among all its terms is 3. So if you look at the graph, this can be described in a different way. They could say the 3 points on the graph are 0, 0, 2, 0, and 5, 0. And then here's another point, 3, 12, that lies on the curve, right? So all these points are x-intercepts, and we saw earlier that if they are x-intercept, then they can be used to find the factors. So let's write a factor for each point. So this is 0. That means one of the factors, let's put f of x, one of the factors is x minus 0. Because it's x minus 0, when you equate that to 0, x will just be equal to 0. Another factor is x minus the opposite of this one. So it's positive 2, so that means x minus 2. So why am I reversing the sign? Because if I want to get the x by itself, I have to move the 2 to the other side, and that's how it will become positive. There you go. So if you have a positive number, then you plug it in into the formula x minus p or x minus q, it becomes x minus 2. Conversely, if you have, let's say, a negative number, negative 5, and you plug that in, it will be x minus negative 5, which changes it into x plus 5. Okay, but let's erase that. We don't need that. So going back, we've used the 2. So now, oops. So now let's use the 5, 0. So we have x minus 5. So those are the 3 intercepts. Oh, how come we didn't use this one? The y-intercept is not 0. So it cannot be used for the factors. However, you're going to use that later on when you find the value of a at the beginning. So remember, in the intercept form, there's an a and then all the other factors. Okay, so let's clean it up a little bit. So I have f of x equals, we're going to find a later. Now, x minus 0 will just become x. Then this one can be done by your rainbow method or box method. It will be equal to x squared. So that's x squared, right? That's minus 5x minus 2x plus 10. So combining like terms, you will get minus 7x plus 10. And then if you distribute the x variable, which is here at the beginning, you will have f of x is equal to, again, we're going to keep that a right there because we need to find it. Distribute this one, you get x to the 3rd power minus 7x squared plus 10x. Okay, so now we're going to use this point to find a. Remember, your first coordinate is x, the second coordinate is y. So the 3 gets plugged in, and then the 12 is for the y. So let's substitute 12 for y equals a. Now, when you substitute the 3, you have the option to substitute it in the first or substitute it in this equation. Okay, well, which one is simpler? If I substitute it here, they are broken down, it's easier to compute. So if I substitute 3 there, and here, so I will get 3 minus 0 is a 3, then 3 minus 2, that's 1, and then 3 minus 5 is negative 2. That's a lot easier compared to when I compute it here, I go, oh, so 3 cubed minus 7, 3 squared, and so on. So it's your choice, but you will get the same answer. So we get 12 is equal to, this turns out to be 3 times 1 is 3 times negative 2 is negative 6. So negative 6a. So when you divide both sides by negative 6, you get a is equal to negative 2. There you go. So the final answer, I'm just going to leave it in intercept form. So, oh, you just have to distribute it here. Sorry, I forgot. So a is negative 2 here. So you just have to distribute it to your trinomial. So you get negative 2x cubed plus, because negative 2 times negative 7 is positive 14. So positive 14x squared. And then 10x times negative 2 will become negative 20. So that's the final answer in standard form. There we go. Alright, so those are some examples on how to write functions. I showed you an example on quadratic and one also on cubic functions, just by knowing the intercepts of the graph.